Welcome to The Explainer. Today, we're diving into a genuinely fascinating 2026 paper from researchers at Yale and Google Research. We are tackling one of artificial intelligence's absolute biggest, most dangerous flaws. It's overconfidence. We're talking about teaching language models to actually know what they do not know.
So let's just lay out the massive problem we're facing right now. When large language models are let loose in high-stakes arenas, think medicine, scientific discovery, or high-level legal consulting, they routinely hallucinate. But the crazy part? They do it with absolute, unwavering certainty. Just imagine a doctor or lawyer relying on an AI assistant that hands them a completely fabricated legal citation, or worse, a dangerous medical diagnosis, but presents it with the exact same unshakable confidence as a proven scientific fact. It's not just a minor glitch, right? It literally undermines the entire foundation of trusting these systems.
Which immediately begs the question, why on earth do these incredibly advanced models confidently lie to our faces? Well, the researchers point out that current AI is missing a massive cognitive piece of the puzzle. It completely fails to recognize its own knowledge boundaries. It systematically misrepresents its internal uncertainty simply because, well, it's never actually been trained to accurately assess its own performance limits. To figure out how we fix this, our agenda is going to guide us through this whole confident AI problem. We'll define what metacognition actually is, break down the brand new RLMF framework, look at how we translate robotic numbers into human words, and finally, check out the state-of-the-art results.
All right, Section 1. What exactly is AI metacognition? Let's talk about AI self-awareness.
The definition of metacognition is super interesting. Think about it in human terms. It's how you and I know when we need to study a bit more for a test or when we naturally hesitate before answering a really tricky question. For an AI, metacognition means having the self-awareness to accurately judge its own performance and capability limits. Because logically, if a model can monitor its own performance, it is in a way better positioned to actually improve it.
So the absolutely crucial distinction here is between factual calibration and faithful calibration. Factual calibration just means, spitting out the right answer based on reality. But here's the catch. An AI might totally guess the right answer while internally being completely clueless. Faithful calibration, on the other hand, means accurately reflecting the model's true internal uncertainty. We don't just want the AI to happen to be empirically right, we want to ensure you, the user, can actually trust its confidence level. We want what the AI says to perfectly align with what it actually believes under the hood.
Moving right along to Section 2, RLMF, which is a totally new training approach.
This new pipeline is called reinforcement learning with metacognitive feedback, or RLMF for short. It's essentially a brilliant roadmap of how the model gets from receiving a raw query to expressing faithful uncertainty, and we don't even need to get bogged down in all the complex advantage scaling math to understand it. At its core, this is a mechanism that hardwires metacognitive awareness into these models while simultaneously boosting their actual task performance.
We can actually break this down into 3 straightforward steps. First up, the model generates a bunch of possible responses. Second, it assesses its own performance, basically predicting how faithful its own confidence scores are. And third, its learning signal, or what they call the advantage, is scaled based on how accurate that self-judgment was. It's this ingenious feedback loop where the AI is literally forced to look in the mirror before it gets its final grade.
Think of standard reinforcement learning, kind of like grading a student solely on getting the right answer on a multiple-choice test. They might have totally guessed, but hey, they still get an A, right? RLMF, though, rewards the student for getting the right answer plus knowing exactly how sure they were about it. If they got it right but internally thought they were going to be wrong, the reward actually gets slashed. They only get the maximum reward when their performance and their self-awareness match up perfectly. On top of that, the researchers use something called metacognitive data selection. This is where the AI essentially acts as its own teacher. It scores its own candidate training examples based on how well it thinks it performed. And then, this is the cool part, it deliberately picks the absolute best and the absolute worst self-assessments to learn from. Why the worst? Because just like us humans, the AI learns a ton from its most spectacular moments of confusion. This self-curated approach just completely blows traditional, naive, active learning methods out of the water.
Okay, Section 3, translating numbers to words. This is all about linguistic uncertainty.
This decoupled approach is honestly brilliant. First, the AI produces a perfectly calibrated internal numerical score. But let's be real, users don't want to chat with a bot that says confidence 0.73. So they translate this robotic numerical confidence into human-aligned linguistic hedging. They dynamically edit the output using a mapping strategy so the AI sounds naturally cautious. So, confidence point 73 magically becomes, I'm reasonably sure that, whereas a 0.95 might become, it's an established fact. It totally avoids that repetitive, unnatural robot speak of older models and lets the AI adapt its tone naturally based on what the user actually wants without needing a full-blown retraining.
Which brings us to Section 4, the state-of-the-art results. Let's see how this actually performs.
Let's look at how this metacognitive training holds up in the real world against standard models. Spoiler alert, it's huge. By optimizing for this metacognitive ability, RLMF achieves up to a staggering 63% improvement over standard reinforcement learning when it comes to faithful calibration. And here's the kicker. Earlier methods that tried to force AI to express uncertainty, like just using clever prompting, usually ended up wrecking the model's actual task accuracy. But RLMF preserves the accuracy while hitting this massive 63% leap in calibration.
When you map this out on a reliability diagram, looking for that perfect diagonal line of alignment, the RLMF model shows a remarkably tight alignment between intrinsic confidence and expressed confidence across the board. It essentially proves that this framework successfully aligns what the model says with what it actually believes. It completely eliminates that terrifying danger zone where the AI is internally clueless but externally 100% confident.
But what is truly incredible about this data is that this approach allows smaller, open-source 8 billion parameter models to absolutely crush the proprietary industry giants. Using RLMF, these smaller models boast massive, faithful calibration gains over frontier models like GPT-5, outperforming it by 37% and beating Gemini 3.1 Pro by 17%. And keep in mind, that's even when those giant models are using highly specialized metacognitive prompting. The smaller model is, simply put, just way more self-aware.
So I want to leave you with this final provocative thought. If artificial intelligence can now accurately monitor, judge, and actually learn from its own cognitive limits, literally using its own self-assessments to curate its own training data, are we finally crossing the threshold into truly self-directed AI? It is a thrilling and, maybe slightly daunting look at the future of machine intelligence. Thanks for hanging out with me for this explainer, and remember, keep questioning the confidence of everything you read.